Now let's take a look at how to invert a 3 by 3 matrix. So the 3 by 3 case. So once again, let's work with something we have already. Let's just make up a matrix, doesn't matter. So suppose I'm making up P, which is 6, 2, 0, 9, 4, 1, 3, 0, 7. Okay, we've made it up. Okay. So let's go step by step. Doesn't matter if we have a 2 by 2 or a 3 by 3 or any x by x case. The 6 steps that we have to follow are the same. So this is a 3 by 3 matrix. So the first criteria, the squareness criteria, is satisfied. So is a square matrix. This is done. Okay. Second step, we have to calculate the determinant of P. So determinant of P, you can either write it like this, or you can write this. They both mean the same thing. So determinant of P is equal to, once again, I'm rushing through this. I'm going to go very quickly. Feel free to take your time and solve it yourself. So this gives us 6. And plus, no wait, this is minus, plus 0 times whatever, it doesn't really matter because it is 0, right? So 6, how much do we get here? 28 minus 0 minus 2, 63 minus 3. So we have 168 minus 120. Did I do that correctly? Yeah. So we get 48. Okay, which is obviously not equal to 0. So we know that the determinant of P is not equal to 0. So P is non-singular. Let's write that down. P is singular. And since P is non-singular, it means that a determinant, an inverse of P exists. Okay. Part 3, remember, was calculating the, what was it? The minor matrix. Even I forget sometimes. Okay. So let's just bring P down here. It's going to help us. So 620 941 307. So this obviously, once again, if it helps, you can write it down: P11, P12, P13, P21, P22, P23, P32, and P33. So we have this. We're going to calculate the minor. So we want to find M11, M12, M13. So remember, the steps are all the same. This is just a bigger matrix. So how did we calculate the minor of the 2 by 2 matrix? So for M11, to calculate M11, what we did was we went to P11 and we ignored everything in the same row and the same column. And we are going to do exactly that. What that is going to give us, this again. And what that is going to give us now is a 2 by 2 matrix. So it's a bit lengthy, but the same thing really. So once again, now M12, so we come to P12, we ignore everything in the same row and column, and what's left, we take. Okay. So once again, I'm going to erase this. For M13, we get 9430, 2007, 6037, 6230, 2041, 6091, and 6294. Okay. So effectively, you guys already know what's coming is we are going to be calculating the determinants of all these 2 by 2 matrices. So what we get is that M11 is 28, M12 is 63, M13 is minus 12, M21 is 14, M22 is 63, is it? No, sorry, 42. 3 is minus 6, 31 is 2, M32 is 6, M33 is 24 minus 18, so 6. So if we write down the minor matrix, that gives us 28, 60, minus 12, 14, 42, minus 6, 2, 6, 6. Okay. This is the minor matrix. This is step 3, was it? Step 3 done. Step 4 is to calculate the cofactor matrix. And cofactor matrix, if you remember, was just changing the signs. So this will remain as 28. This is minus 60. This is minus 12, minus 14, 42, 6, 2, minus 6, 6. So once again, I rushed through this, but have already shown you guys the method of what will remain as positive, what will see its sign change, and which element will not see its sign change. So just go back to that and go through it again. So we've got the cofactor matrix. 5 is calculating the adjoint of P. Remember, that is just the transpose of the cofactor. So what does that give us? 28 minus 60 minus 12 minus 14, 42, 6, 2 minus 6, 6. This is the adjoint of P. This is step 5 done. Step 6, P inverse is equal to 1 by determinant of P times the adjoint of P, and this is just the formula that I've showed you guys already. So if we do that, determinant, if you remember, was 48. So 1 by 48 divided by 28 minus 14, 2, 60, 42, minus 6, minus 12, 6, 6. And that is the inverse of P. So to sum up, we go all the way back. We started off with this matrix P. In step 1, we made sure it is a square matrix. It was a 3 by 3, so a square matrix. In step 2, we made sure P is non-singular. It was. Then we calculated the minor. It was a bit of a lengthy process, but once again, lengthy and difficult are two different things. This is a lengthy process. There is a lot to do, but each individual step is very easy. So, okay, and then we calculated the cofactor. We calculated the adjoint, and then finally we calculated the inverse, which is this.